One of the most amazing tales in nature is their transformation from deer-like forebears to enormous giants. The evolution of the giraffe, however, was a remarkable story of survival, rivalry, and ingenuity, rather than merely reaching for trees. Welcome to this in-depth exploration of giraffe evolution. From their modest origins as creatures that lived in forests to the titans of the African savanna, we will discover all of the key ancestors today. Along the way, we'll learn that the giraffe's neck is only the tip of the evolutionary iceberg. Our story began approximately 25 million years ago, during the Oligocene epoch. During this period, the Earth's climate cooled, and the very face of the Earth began to change. The forests that once ruled were replaced with vast plains, changing the way animals lived and fed. Among the mammals that adjusted to these changes were ruminants, which had four-chambered stomachs designed to break down tough vegetation. One group of ruminants, known as pecarins, began to prosper. These species laid the groundwork for modern giraffes, deer, and antelope. They had efficient limbs for running and browsing. But giraffes' direct ancestors did not appear until the Miocene epoch, when significant evolutionary changes set the stage for the unique lineage we recognize today. This brings us to Canthomeryx, which marks the beginning of the giraffe's journey as a separate lineage. Fossils reveal that Canthomeryx, a deer-like animal roughly the size of an antelope, lived in Africa some 20 million years ago. Yet, it stood out with early characteristics that hinted at the giraffe's future: slightly elongated limbs and necks, setting the stage for what was to come. From this humble beginning, two evolutionary pathways emerged, one leading to the modern giraffe, and the other to the okapi, its elusive forest-dwelling cousin. These two animals would evolve into drastically different species, with one adapting to dense forests and the other dominating open savannas. Around 15 million years ago, another key ancestor appeared, Paleotragus. This giraffid marked an important turning point in the journey. Taller than its predecessors but with a neck shorter than modern giraffes, Paleotragus was perfectly adapted for browsing higher vegetation, such as shrubs and small trees. As Paleotragus spread across Africa and parts of Europe, its body structure and diet evolved to match its environment. Its ossicones, the horn-like structures seen in giraffes today, began to take shape, and its teeth were specialized for chewing tough leaves. This ancestor bridges the gap between early ruminants and the more specialized giraffids that followed. Fast forward to about 7 million years ago, and we encounter the extraordinary Civatherium. This giant giraffid, often described as a mix between a giraffe and a moose, represented a different evolutionary experiment. Weighing up to 1,200 kilograms and standing over 2.5 meters tall, Civatherium was far bulkier than modern giraffes. Its fossils, found in both Africa and India, reveal that it had large, flat, crown-like ossicones. Remarkably, cave paintings suggest that Civatherium might have coexisted with early humans as recently as 8,000 years ago. Around the same time as Civatherium was roaming the plains, Samotherium, another giraffid, appeared. This species fills the gap between giraffes of the past and now. Samotherium exhibited a variety of traits, with a neck that was longer than that of its ancestors, but shorter than that of modern giraffes. Because of its characteristics for both running and browsing, it was a successful and adaptable species. Its slightly elongated limbs also suggest an increasing focus on speed and agility, likely to evade predators in more open habitats. The evolutionary journey continued with Bolinia, which appeared around 7 million years ago in Europe and Asia. This ancestor was strikingly similar to modern giraffes, with a long neck and specialized legs perfectly suited for open savanna habitats. Feeding on the dense foliage of tall trees, Bolinia thrived in these environments. Eventually, Bolinia's descendants migrated to Africa, where they adapted to the continent's unique challenges. These adaptations, including further elongation of the neck and refinement of their cardiovascular systems, paved the way for the emergence of the modern giraffe. About 1 million years ago, the current genus Giraffa made its debut. Early species, such as Giraffa gracilis, were smaller and more slender, but eventually evolved into the tallest land mammals on Earth. Standing up to 5.5 meters tall, modern giraffes are marvels of evolution, equipped with powerful hearts, intricate blood flow systems, and elongated neck vertebrae that fuse during development. These adaptations allowed giraffes to not only survive, but thrive in their unique ecological niche. But the giraffe story wouldn't be complete without mentioning its closest living relative, the okapi. Found in the dense forests of Central Africa, the okapi offers a fascinating glimpse into the past. With zebra-like stripes on its legs, a shorter neck, and a giraffe-like prehensile tongue, the okapi represents the branch of giraffids that diverged from the giraffe lineage around 10 million years ago. Its long tongue, used for stripping leaves and even cleaning its eyes and ears, is a direct link to its giraffid heritage. Solitary and secretive by nature, the okapi remained unknown to the Western world until the early 20th century, and even today, much about its behavior remains a mystery. The okapi's ability to blend into dense forests highlights the incredible diversity of the giraffid family and its capacity to adapt to vastly different environments. Giraffes are now the last towering sentinels of a once diverse and vibrant lineage, a family that spanned continents and included extraordinary forms, ranging from the deer-like Canthumeryx to the massive Civatherium. With characteristics like their long necks, strong hearts, and distinctive spotted patterns, giraffes have developed over millions of years into nature's skyscrapers, perfectly suited to their surroundings. Although the giraffe's long neck is arguably the most striking illustration of evolutionary brilliance, why did it evolve? It is generally believed that this adaptation enabled giraffes to consume tall trees that other herbivores couldn't reach. However, there is a compelling argument for sexual selection. Male giraffes use their long necks in a practice known as necking, which occurs during severe power contests. Because stronger necks often lead to victory, these duels are crucial to successful mating. Sexual selection and nutritional advantages probably combined to create the distinctive size that we see today in giraffes. If you enjoyed this journey through time, consider subscribing for more deep dives into the animal kingdom. Which animal evolution should we explore next? Let us know in the comments.